Our next presenter is the defending champion of the spirit of innovation. Here to compete for back-to-back titles, the town of Qualicum Beach, presenting fast and frictionless AI-powered innovation. Please welcome Reno Sun.
Hello everyone, my name is Reno Sun, Manager of IT and GIS, working at the town of Qualicum Beach. I'm honored to be here to share how we build AI-powered solutions to solve real municipal challenges. Qualicum Beach is about 2-hour drive north of Victoria. We have about 75 dedicated staff. Our IT and GIS team is small, just about 3 of us, plus an awesome IT service provider. Now, I will walk you through 2 exciting AI and automation powered solutions that turn real pains into real gains. The town website document library, Semantic search, and the legacy service car, data extraction and automation solutions. Our town website document library runs on SharePoint as the single source of truth is fully integrated with town's website. So any updates staff made in SharePoint document library would be instantly reflected on the public site. Let me show you 2 examples where keyword search fails. When we searched mobile device policy, the most relevant document shows up at result number 13th, because keyword search doesn't understand the intent behind the query. When I searched with keywords like sidewalk policy, keyword search returned the sidewalk policy that I am looking for at result number 18th. It was hidden all the way at the end of the search result. In early June this year, Microsoft released the Copilot Retrieval API preview, which can semantically search across SharePoint document libraries to find the most relevant documents based on users' search query. We saw this as a great opportunity to test its accuracy and performance to see how well it can semantically search our document library and return relevant results. We believe this could be the silver bullet to address the pain points of our current keyword-based search. Then, we built an internal semantic search app using F&E Flow app to test and show how Retrieval API works, starting with our internal stakeholders. The app allows users to semantically search the document library with over 6,000 documents and return relevant documents that users are looking for. We successfully used Copilot Retrieval API to semantically search the document library, pulling document names, URLs, relevance score, relevant content, and their page numbers. F&E was used to generate responsive and dynamic HTML for showing all search results. And all codes were built quickly with vibe coding. Both GenAI and the F&E allow us to build frictionless solution very quickly. Now I will show you how semantic search works with 2 quick demos to compare it to keyword search. When I searched mobile device policy again, it returned correct documents right at the top search results. Previously, keyword search buried way down to the list at the number 13 search result. When I search with question, do you have any sidewalk-related policy? The semantic search returned town sidewalk policy right at the top again, something keyword search buried way to the bottom previously. Also, the keyword search cannot handle very well with natural language queries, but semantic search can handle both keywords and the natural language queries. These are just iceberg of examples successfully shows how much more effective semantic search is compared to keyword search. We built a semantic search app in just 5 workdays to solve internal staff struggle with poor keyword search. The town's key stakeholders responded with strong support and positive feedback, which increased the support to replace keyword search with semantic search on our public site next year. Since Copilot Retrieval API is still in preview and can only handle 200 requests per hour and only return up to 25 search results per search, we need to look for AI API that is more suitable for production use. Therefore, we will be working with GovAI, our current AI solution, to build production-ready semantic search features against SharePoint document libraries using their API, web crawler, and SharePoint connector in near future. We are also aiming to build a non-intrusive public-facing semantic search feature that can not only search document library, but also web pages on our town website. Still remember, there's a second exciting solution that I mentioned previously for legacy service cards data extraction. Before we dive into the next solution, let's talk about what a service card is. A service card is a key document that records utility connections information like for water, sanitary sewer, and storm drainage. Service cards are vital for BC1 calls, call before you dig services, for underground utility providers to ensure safe installation and maintenance. For residents, they provide essential information about their property's utility services, helping with maintenance and service decisions. These cards are important for both staff and the public. Now, let's talk about legacy service card data extraction solution. In February, we joined an FNE webinar that a consultant from Avini and Tenzin showed how they extract data from 1 million service cards for a UK utility company in just 26 hours AI processing time using FNE and Google Gemini API, with computing cost only about 170 Canadian dollars. If this is done manually, they estimate it will take about 19 years. After the webinar, we had a hands-on training with Avini and Tenzin consultants, and quickly we learned how to use Gen AI to extract data from our legacy service cards. We were encouraged to tackle our own 4,400 PDF-based service cards mixed with digital and handwritten text by using FNE and Gen AI. Our goal is to build a solution to cost-effectively extract all services cards directly into our enterprise geodatabase and correct them with minimal manual efforts. In the future, we would like to use this data to generate dynamic and user-friendly digital service cards like the District of North Vancouver's Service Connection Report, and also many other municipalities have this type of beautiful service cards. We share our desire to build a legacy service card data extraction solution to GovAI, as we are one of their early partners. And they saw it as a great opportunity to design and develop a data extraction API and other related features together. This joint effort allowing the town to continuously refine our data extraction processes and accuracy using the API built by GovAI. Therefore, we built an FNE automation to perform data extraction process with GovAI's data extraction API. GovAI also guarantees Canadian data residency and privacy law compliance compared to Gemini, which is very important to us. We split our data extraction processes into 2 stages. Most AI data extraction APIs need 2 things: your instructions or rules in a prompt, and a JSON schema that tells AI how to format the data extraction outputs. However, sometimes the schema alone itself is enough for the entire data extraction. Breaking prompts and schemas into 2 separate stages greatly reduce hallucinations and give more accurate results than dumping everything into one big prompt. In stage 1, We send each service card to the data extraction API with a simple prompt and schema, asking it to pull every field as raw text into JSON. After submission, we get job IDs, letting us get all extracted records in JSON when they are ready. In stage 2, we ran QA/QC jobs with about 20+ rules in the prompt to clean, standardize, and strictly format the stage 1 output. So many manual jobs has been eliminated, and the output of stage 2 data extraction is way more accurate and standardized. In stage 2, we added stricter format rules. For example, datetime-related fields now follow standardized datetime format, and numbers are enforced as numeric fields, which in stage 1, we track everything as raw texts because we didn't want to overwhelm AI in the first stage. We also enrich some schema fields with detailed descriptions. For example, the type of pipe field now has full lookup list of abbreviations and layer long forms. These descriptions act like a mini prompts in the schema JSON, helping AI give precise, standardized outputs. Here are some examples of stage 2 prompts showing how we guide AI to perform some QC tasks, such as asking it to standardize the location and place field, output by replacing common abbreviations and symbols with a consistent format, or asking it to auto-convert all imperial units to metric with a decimal rounding rule. GovAI has also developed a data extraction dashboard, help us easily track status, performance, review prompts, schemas, and historical data extraction output. There's also a built-in playground, allowing us to test, generate, or refine our data extraction prompts and schemas effectively. Of course, there are challenges, like a messy, tiny, or faded handwriting. Some of these challenges can be reduced with image enhancement tool or image enhancement AI. AI can sometimes also pull the wrong values from wrong cells, or even make things up if overloaded. We reduce this type of hallucination by splitting one big prompt into 2 stages, as shown previously. We have about 4,400 service cards. If we manually converting them, it would take about 63 workdays. With F&E and GovAI, extraction now takes just 15 seconds of AI processing time, and the average 2 minutes of human QC per card. This is not only greatly reducing processing existing service cards into digital records, but also for all new cards in the future. All new cards will be with digital text only, without handwriting, so AI will handle them far more accurately. The processing time will keep getting faster as we keep optimizing our prompts, schema, QC tools, AI models, and automation flows. I know this may not look like it's saving a lot, but let's imagine if you need to extract data from 1 million service cards or other different type of legacy documents. The cost saving using AI in this case will be huge. In the future, we will follow the best practice to keep refining our prompts and schemas by breaking them into stages if needed for better accuracy. We will also continuously work with GovAI, again, to build an evaluation tool that can systematically or scientifically show us how changes made to prompts or schemas impact data extraction outputs compared to human corrected outputs over time with a dynamic dashboard. This will help us to refine the service cards data extraction solution to hopefully near 100% accuracy. In summary, we have transformed how we work by automating service card data extraction and improving document search. We have saved staff time and reduced frustrations, a big win for a small team. We have shown how F&E and generative AI makes everyday tasks more efficient, and these tools can be reused for similar future projects. Best of all, our approach can be shared with other local governments easily, regardless their sizes, and you can choose to use different AI or automation tools. We have truly turned pains into gains with our fast and frictionless AI-powered solutions. Thank you.